For number 91, we're actually looking at a clock. There's a picture of a clock in the book, and it says the minute hand of the clock is 6 inches long, so I labeled that. I don't need to draw a clock. And it says, how far does the tip of the minute hand move in 15 minutes? So to interpret what this is asking, it's asking you've got the minute hand starting there, the tip of the minute hand, and the minute hand in 15 minutes would move from this point here to this point here. Got to assume that it's at the edge of the clock, so that would be the arc length. So really we're trying to find the length of that arc. And we should recognize that in 15 minutes, that's 1/4 of an hour. So if you take 15 minutes, and I'm doing this so that you can see how to do this other one. If you take 15 minutes and need to get it to 1/4 of an hour, if you multiply that by 1 hour over 60 minutes, so basically you're dividing this number by 60. So if you take the minutes cancel, 15 goes into 60 4 times, and you get 1/4 of an hour. Well, 1/4 of an hour still hasn't gotten us to radians yet. So 1/4 of an hour is basically 1/4 of the circle. So we really want, since we want the length of the arc, we know that the length of the arc is r times theta. So your job is to figure out what that theta is in terms of radians. So we could see, perhaps maybe we know that 1/4 of the circle is 90 degrees. Maybe we already remember that's pi over 2. But let's just say you didn't remember that, because I want to show you how to do it, kind of generate the angle in radians, how you would generate the angle in radians over here. So if we take 1/4 of an hour equals how many radians, so if we do that, then we take 1/4 of the hour, and how many radians is it all the way around? Well, that's the circumference of the circle. Sorry, scratch that. 1/4 of the way around in angle measure, so the angle all the way around is 2 pi radians. So that's what you should know. You should know that all the way around the circle is 2 pi radians, and if we take 1/4 of that 2 pi, then we get pi over 2. So 1/4 of the 2 pi is pi over 2 radians, and that's our theta. So we can take that number and we can put it right in for that theta. We already know the r is 6, and if we take that theta, put it in pi over 2, we get 2 goes into 6 3 times, and we get 3 pi. Now it's not going to be radians because it's length of an arc, but what is that in 6 inches? So it's 3 pi inches, and that would be how far that minute hand would travel in 15 minutes, 3 pi inches. I'm going to go ahead and do the second part of 9. No, I'll go ahead and do that now. Try to get in the same video. So what we really want to find out is 25 minutes is equal to how many radians? Well, we take 25 minutes and we have to multiply that by 1 hour over 60 minutes. We want to figure out what fraction of the hour that we've got there. So we cancel the minutes. 5 goes into 25 5 times, and 5 goes into 60 12 times. So we have 5/12 of an hour. Okay, so if we have 5/12 of an hour, what we really have is 5/12 of the circle that angle is, and 5/12 of the circle, we multiply 5/12 times 2 pi, because all the way around is 2 pi. Multiplying that fraction of all the way around, we multiply it by 2 pi, and the 2 goes into 2 1 time, 2 goes into 12 6 times, so we have 5 pi over 6. So the angle is 5 pi over 6. So when the minute hand moves 25 minutes, it's moved an angle of 5 pi over 6 radians. And so now we just we have to figure out how far the minute hand moved along the circle, along the clock, and that's really what we're trying to find. We're trying to find the length of S, that arc, and S is r times theta, and r again is 6. And I forgot to write the 6 there. That's 6 inches. So 6 inches, and so we multiply that by 5 pi over 6 and radians, and we see we can cancel the 6's, and we just get 5 pi. So it moved 5 pi inches in 25 minutes. that is it.